All right, class, hello. Today we're going to be talking more about matrices and more particular special things that we can do with matrices besides adding, subtracting, or multiplying. And the new phrases that we're going to be talking about are determinants and inverses. Okay? So let's first talk about what a determinant is. Well, a determinant is a number, a real number that's associated with a square matrix. So we can only have determinants of matrices when the matrix is a square matrix. What does it mean to be a square matrix? When the number of rows is the same as the number of columns. In other words, when m is equal to n. Okay? And we denote that determinant of the matrix by either the phrase determinant of the matrix A or absolute value of A, which represents the determinant. So let's take a look at how we were to calculate the determinant of a matrix. Now I'm going to show you two ways to compute the determinant of a matrix depending on the size of the matrix. Remember, matrices can only have determinants if the matrices are square. In other words, the rows is equal to the number of columns. So we're going to take a look at the first example, which is a 2 by 2 matrix. And you guys might have had experience with calculating the determinant of the matrix. If I have a matrix A, B, C, D, which are the entries, then I can find the determinant of the matrix by taking the difference of two products. The first product is A times D, and the second product is B times C. Okay? Or C times B. It has to be in this format. It has to be the top left and the bottom right multiplied together by the top right and the bottom left. Okay? And that's how you calculate the determinant of a 2 by 2 matrix. Now, the determinant of a 3 by 3 matrix can be found by basically doing a bunch of determinants of 2 by 2 matrices, but I'm going to show you the shortcut. And this is for the next largest square matrix, which is a 3 by 3 matrix. And the determinant of this matrix can be found very simply by rewriting the first two columns of the matrix. As we can see right here, I rewrote the first two columns. Here's column 1, here's column 1, and here's column 2, here's column 2. Okay? And then what I'm going to do is I'm going to find the result of the difference, again, of products, but really it's the difference of the sum of certain products. So let's take a look. I'm going to take, starting at the top left, I'm going to multiply across A times E times I. Then start from the next entry, multiply diagonally, B times F times G. And then C times D times H. And I'm going to add those values up. And then I'm going to subtract from that sum the difference of a combination of other multiples, starting from the bottom left and then going up, GEC, HFA, and IDB. Oops, sorry. Okay. So let's take a look at an example before we go any further. So here we have a 2 by 2 matrix, and here we have a 3 by 3 matrix. Again, they have different processes to evaluate the determinant. For this one, we're going to multiply diagonally, 4 times 2, and then multiply diagonally, 5 times negative 3, and then we're going to subtract those products. So 8 minus a negative 15 is 23. To do the 3 by 3 matrix, so the determinant of this matrix is 23. To do the 3 by 3 matrix, remember it's 3 by 3, so we're going to rewrite the first two rows, negative 1, 0, 1, 3, 2, and then we're going to perform our series of diagonal multiplication products. 1, 3, 6, which is 18, 1, 4, 0, which is 0, 2, negative 1, 2, which is negative 4. And then we're going to start from the bottom left and go up 0, 3, 2, which is 0, 2, 4, 1, which is 8, and 6, negative 1, negative 6, which is negative 6. I'm sorry, 6, negative 1, 1, which is negative 6. Then we're going to add up the results of each sum of products. So we get 14 here, and we get 2 here, and we subtract the 2, and we get 12. Okay? If you have more questions, I encourage you to practice or look at some of these problems. I'm going to give you some problems for you to. Now, I know the steps may have been confusing, but they're actually quite easy to do. So I encourage you to rewind the part if you're confused about any of those things. Now, I know some of you are saying, what about if I have a 4 by 4 matrix or a 5 by 5 matrix? Well, you can still compute the determinants using some algebraic or arithmetic properties, but it takes a very long time. So in those situations, I would encourage you to use the calculator to find the determinant. But I'm not going to give you any problems where you would need to use the calculator to find the determinant. You can either use this method or this method because those are the only type of problems I'm going to give you to solve. Okay, so now let's take a look at inverse. Before we can talk about inverses, we need to specify what an identity matrix is. And some of you have experience with that from one of the CLAs. An identity matrix is a square matrix, n by n. The number of rows is the number of columns. And the only values that are entries are ones and zeros. And more importantly, ones are on the diagonal and zeros are elsewhere. That's for a 2 by 2. And the identity matrix for a 3 by 3 would have the ones on the diagonals and the zeros elsewhere. Okay, so that's an important matrix. And when you, for those of you who use the identity matrix in the CLA, you would know why. But why is it important for inverses? Well, a square matrix, again, we're only dealing with square matrices, has an inverse if there is some other matrix B that when I multiply A times B, I'm going to get the identity matrix. Okay, so if A times B is equal to, we call the identity matrix I, then that means that the inverse of A is the B matrix, and the inverse of the B matrix is A. Okay, so we're going to take a look at an example of that. Before we take a look at an example, I want to tell you that it's very easy to determine the inverse of a 2 by 2 matrix. And some of you have experience with that from the previous CLA. What you can do, if I have a 2 by 2 matrix, to figure out the inverse of the 2 by 2 matrix, I need to do two things. I need to find the determinant of this matrix, which we know the determinant of this matrix is A times B minus B times C. And I divide that by 1, and I multiply that by a special matrix, which is found by switching the D and the A values. So instead of A here and B here, we have D here and A here. And then changing the signs of the remaining values. So the opposite of whatever B is and the opposite of whatever C is. And when I do that, I will have the inverse of the matrix. And this only works if the determinant is not 0. In other words, if AD minus CB is 0, then we won't be able to find the inverse because we won't be able to calculate 1 over A determinant of A. So in this case, again, a square matrix only has an inverse if the determinant of that matrix is not 0. And this is how we calculate it. Let's take a look at an example. So over here we have a matrix A. It's 2 by 2. And we go through the process that we listed up here. We find the determinant of this matrix. So 3 times negative 4 is negative 12. And 4 times negative 2 is negative 8. So negative 12 minus a negative 8 is 4. So now, negative 4. So now we have to multiply the resulting matrix by 1 over negative 4. Well, what is the resulting matrix? Remember, we switched these two values. So now I have, instead of 3 and negative 4, I have negative 4 and 3. And then I take the opposite of the signs of these values. So instead of negative 2 and 4, I have positive 2 and negative 4. And then I perform my scalar multiplication by multiplying each value by 1 over negative 4. And I end up with this. And this is the inverse of that matrix, A. And how do I know if it's the inverse of that matrix A? I can multiply A times A inverse, which is this matrix, and I promise you, if you do the correct calculations correctly, you will get I, which is the identity matrix 1, 0, 0, 1. So for you to practice, here's a matrix I want you to find the inverse of, and I've actually given you the answer so you can double check your answers to see. Another question will be, well, how do you find the inverse of a 3 by 3 matrix? Well, the process is a little bit more calculation involved, and we'll go over a strategy to do that in class. But for the VA, you need to be able to, first of all, calculate the determinant of a 2 by 2 matrix and a 3 by 3 matrix. And secondly, you need to be able to determine if a matrix will have an inverse. And then you'll have to be able to determine the inverse of a 2 by 2 matrix. Okay? So hope you have a good weekend. Bye-bye.